I am Professor M.V. Malkarnavar, Department of Physics, Government First Grade, Women's College, Jamkandi. Today we have to discuss the BSc First Semester Physics, Unit 3, Angular Momentum. In that Unit 3, Session number 18, that is Law of Conservation of Angular Momentum and Illustrations. You know, in the previous class, law of conservation of angular momentum. In the previous class, you know, torque is nothing but cross product of position vector and force vector. Today we have to discuss the law of conservation of angular momentum. In the previous class, torque applied to a system of particles is given by tau equal to r cross f, and also you know the relation between torque and angular momentum. Torque can also be defined as rate of change of angular momentum, that is dl by dt. Therefore, tau equals to r cross f equals to dl by dt. If external torque is 0, now tau becomes 0. Now the above equation becomes dl by dt equals to 0, or angular momentum L is conserved. Angular momentum L is conserved. Observe here, if tau equals to 0, dl by dt equals to 0, L is conserved. That is, the net force acting on the rotating body is 0. When the net torque acting on the rotating body is 0, then angular momentum of that body remains conserved. This is known as the law of conservation of angular momentum. In case of linear momentum, the net force acting on the body is 0, but in the case of angular momentum, if the net torque acting on the rotating body is 0, then angular momentum of that body remains constant. This is known as the law of conservation of angular momentum. Now we have to go through the illustration. You know, in the previous class, angular momentum can also be defined as the product of moment of inertia and angular velocity, that is L equals to I omega. Differentiating both sides, we get dl by dt equals to d by dt of I omega. But dl by dt is nothing but a torque. Therefore, tau equals to d by dt of I omega. If tau equals to 0, then I omega equals to constant. Remember here, if moment of inertia increases, angular velocity decreases, or if moment of inertia decreases, angular velocity increases, so that the product of moment of inertia and angular velocity constant. Now we go through some illustrations for the law of conservation of angular momentum. The first illustration: during the motion of a planet in its orbit, to conserve its angular momentum, planet must move faster at a point of nearest approach. At that time, its moment of inertia is less. When the planet is near to the sun, at that time it must move faster, because at that time its moment of inertia is less. When it is away from the sun, it must move with a lower velocity, because its moment of inertia is more, so that the product of inertia and angular velocity constant. Now go through the second illustration. that is scattering of charge by massive nucleus. When positive charged particle approaches the nucleus, repulsive force goes on increasing. As a result, the positively charged particle deflected or scattered in a parabolic path to conserve angular momentum of the particle. Now go through the third illustration. A person holding two weights in his hands stretched outwards, standing on turntable. When turntable starts rotating, and if the person pulls his hands inwards, automatically his moment of inertia decreases and angular velocity increases. As there is no external torque acting on the system, the angular momentum is conserved. Thank you to one and all.